So first you have to launch Pymo and go to Plugin Manager and install new plugin and find the Pyshifts plugin.py file that you just copied from our GitHub site. And after you have installed Pyshifts plugin, you can go to Plugin and open Pyshifts. So here in this window, you can see there are a few tabs: the options, error analysis, and advanced options, and there's also an about. So in this video, the basic use, I'll only talk about the options and error analysis. So there, in the options, you can choose mode, which mode you want to use in this analysis, and the chemical shift file is a measured chemical shift file, which will be used as a reference, and the predicted chemical shift file is only used in other mode. So after you click on execute, Pyshifts will automatically predict the chemical shifts for you from the structure provided. So in this case, we're using a test structure of 2K OC. There's a progress bar in the Pyshifts window. It will show how many percentages are you on in your current work, in your current program progress. And after you have finished predicting chemical shifts, you can go to error analysis and compare shifts. So after you compare shifts, there will be a table called error table shown in the error analysis tab, and the top 10 best states are also shown in your Pymo window. And the states are ranked by the nuclei and matrix you select. So in the Pymo window, you can choose only a few states you want to visualize. The spheres are a visualization of the errors. The larger the sphere, the larger the error on that nuclei. So in error table, you can select a single state, and that state you selected will be shown in Pymo. And at the same time, a chemical shift table will appear on the right. In chemical shift table, all the chemical shifts and errors of all the residues in your selected state will be shown. And if you select one residue from the chemical shift table, it will be highlighted in MacPymo using a yellow sphere. If you select another state and sort the chemical shift table by error. So if you sort the chemical shift table by residue ID, it is simply from 1 to whatever you have. And if you sort chemical shift table by error, it will be in reverse order, so from largest to lowest error. And you can also sort error table by different nuclei and different metrics. So the default setting is using the MAE for all the nucleus, but you can choose and you can customize it. So click on the nuclei and metric you want and click sort. You will have a different error table. If you use only a certain kind of nucleus in the Pymo, it will only show the error of the nuclei you select. So for example, if you use proton, there will only be the data for proton in the chemical shift table, and you can only visualize the error of proton in the Pymo window. And after you have visualized your errors, you can save the data you generate, like the error table. the chemical shift table and the save single state. So the chemical shift table, by chemical shift table, we mean that the chemical shifts for all the states, for different states. And so we have another selection called save single state, which means save the chemical shift table for only one state, for only the current state you select. So here you select state 1, and the save single state will save the chemical shifts for only state 1. And if you go to the file that I just saved, you can see the error table. In the error table, we saved the data for all different metrics and different nucleus. Since we don't have nitrogen data, a data zero or 0, and the ranking doesn't matter. And the predicted chemical shift table, you have state number, residue name, number, nuclear name, predicted and experiment chemical shifts, and the error between them. And this is a long list because you have all the states. So the single state table, since the state number is included in the file name, there's no state number here in the file. Okay, so that's all for the basic use of Pyshifts. And after you're done, you can click on exit and quit MacPymo.